I'll do an introduction. So welcome to the 911 Advisory Task Force Lunch and Learn for April of 2021. This meeting is being recorded. I want to thank our presenter, John Joseph with Datamark, for being here. And just as a reminder, this is not an endorsement of any particular vendor, but Datamark does have a lot of experience in the field of GIS, and GIS is an important topic for us right now in the state as we are getting close to the end of our migration period from the legacy 911 network to an emergency services IP network. Matthew Gage is also on the call. He is the chair of the GIS committee for the 911 Advisory Task Force. Matt, since this topic is kind of in your wheelhouse, is there anything you'd like to say before we get started?
No, just that the goal for presentation is to sort of come at this from a high level without getting into GIS propeller head weeds that may make a lot of 911 people's eyes glaze over. And I think John will do a very good job at that.
Great. And just a couple housekeeping items. Please mute your microphone if you're not speaking. So that would be pretty much everyone except for John and anyone else from Datamark who's helping him with this presentation during the presentation. At the end, we will have time for questions. If you'd like to get your questions in during the presentation, up on the top right of your screen, there is an icon that looks like three shapes. There's a triangle, a square, and a circle. If you hover over it, it says Activities. If you click on that button, you have an option for breakout rooms, polls, and Q&A. If you click on Q&A, that'll give you a screen where you can actually click the button that says Ask a Question and type your question in. That will queue your question up for the end of the call. We'll also take questions verbally at the end of this, but it'll make it easier if everyone puts their questions in while they think of them during the presentation. And with that, I think I will shut up and I will turn things over to John from Datamark.
Fantastic, Daryl. Thank you so much for going ahead and having us here today. We really appreciate it. This is something we've been talking about doing for a long time. So, you know, the message on here for the start of the meeting course is that, you know, GIS data management for NG901, as Daryl mentioned, we are going to try and keep this fairly high level. And I definitely want to try and follow Matt's lead. You know, he said we don't want to get into the GIS weeds. However, you know, we will be touching on some things that if you're not familiar with those questions, or if you want to go ahead and get more information, definitely engage with us. We want this to be as interactive as possible. Of course, my name is John Joseph. I work with the folks here at Datamark. I've been involved with GIS myself for over 23 years. Spent the last 9 of those years really focused on GIS for public safety. In my earlier life, at one point, I was actually the regional account manager for the folks at Esri. Did a lot of work in the Pacific Northwest. And one of the things I found that I really, really enjoyed and loved was public safety. You can say I drank a little bit too much of Jack's Kool-Aid at some point, but really what it comes down to is, for me, it was the most rewarding aspect of work with GIS in the public space, because you really did feel like you were making a difference. I later went on to go into the public safety space and spent some time working with folks like Geocom and Motorola, and of course now here I am at Datamark. I am currently the commercial advisory member for the state of Idaho for the Apconina chapter. And so I'm definitely very pleased to be here with all of you. And I'm joined today by Brian Brady. And Brian, why don't you go ahead and introduce yourself?
Hello, everybody. My name is Brian Brady. Can you hear me?
Yep, we got you.
Okay. I'm a product specialist for Datamark. I've been in GIS for a little longer than I'd like to admit, just over 30 years. I've designed 3 different systems for NASA in my federal career, and following that, I worked for about 15 in the public safety space in Arizona. Chaired the Governor's Council for GIS. We were the test bed for Next Gen 911 for the state of Arizona, where we stood up the first geospatially routed system in the country based solely on the NENA standard. And that was in full production about 2 months before the standard was released to the general public. So I've been in GIS for a little while.
Very good. Thanks, Brian. Of course, it would not be a Brian Brady presentation without a degree of levity. And we're hoping that what we're going to share to you, it will not cause the same issue as this poor cats that apparently got too involved with theoretical physics. I promise that we'll try not to go too deep today. We'll try and keep this at a high level. And of course, like I said, if there are questions you guys have, feel free to interact with me and kind of, let us know what it is we can help you with. I did want to go through and do a quick review, but I promise I won't spend too much time on this next slide. I think everybody that's in this room probably has seen this slide in one form or another over the last 15 years. This concept behind how an NG911 environment should work, what an I3 environment should look like, and all these different functional elements. I'm not going to go through here and try and recreate the wheel and explain what an I3 network should look like. But I did want to focus on one portion of this, which is really important to what we're talking about today when we talk about GIS for NG911. In our current environment, when we think about our ALI and our MSAG, and how that data is being fostered and facilitated, it's really happening as a tabular data environment. And what we're talking about when we think about NG911, of course, is this transition, right? And this need to move away from these tabular databases into a GIS-based infrastructure. And what some people really don't understand, and not so much at the PSAP level, but I think more at the executive level sometimes, is that, these things like this location validation function and the merge call routing function, they don't come delivered with GIS data already in them. In reality, they are just a holding area, right? You don't get an SI that's already preloaded with a bunch of Google Earth maps or something like that. This data is required to come from the local authority. And so in essence, what we're seeing happening around the country is that the local 911 authority is then facilitating that to be pushed up into this SI and then be delivered to these functional elements of next generation core services. So I have a great analogy that I want to share with you that kind of explains this. So what we're moving away from, right, when we think about, the world that we live in today, is we're moving away from the mystery machine, okay? Now, the good news is that we're moving into a really high-end, Mercedes. We're going to be able to make the gang's all going to fit, including Scooby, okay? But they're going to get where they got to get to much faster, much more efficiency, and they probably won't have to stop by nearly as many haunted mansions. So, this is the transition we're talking about when we think about that migration from a legacy E901 network into the i3 NG901 network. In essence, the GIS that we're talking about today, this is the fuel for NG911, right? And the quality of the fuel we put into this system directly correlates to the efficiency of the engine. So if we're going to go out and buy this really high-end sports car, right, we should have really good fuel we're putting into that engine. And I think another thing that people kind of sometimes forget about is that even if you're in that transitional process of migrating over, there's a direct correlated benefit for the improved GIS for your local systems, right? So that's a really important thing to think about. You're going to have better information that's going to be inside your CAS system, better information that's going into your RMS system. You're going to have better data in general for the systems you're using today, as well as the systems you plan to use in the future. So that's vitally important. So the next piece of this is, I want to kind of talk you through this, how does next generation 911 create this new set of challenges for everyone? And it's pretty clear that this can be a little bit overwhelming, right? And one of the big things we see as a change is that we now have this very clearly defined set of goals, right? It's going to require a lot of collaboration. We're going to have to communicate with one another, and it's going to require a degree of education. So what do I mean when I talk about, this need to define, this need to have this defined set of goals? Well, where is that coming from? Of course, this is coming from these NENA standards. And inside those NENA standards, it defines for us what are the mandatory, conditional, and optional data sets we have. But the part that a lot of people forget about is this idea that when we think about the requirements of NG911, it does define that there is a degree of data completeness that is imperative, right? That it has to be this locally maintained data required. All of those mandatory fields, again, are required. And the reason that they're required is because we have to be able to tie into the folks that are in Nebraska. We need to be able to kind of communicate that stuff back over to the folks in Wyoming. If we have cross-jurisdictional, from state lines and so forth, they're going to be running hopefully off of the same NG911 infrastructure that we are. And so we're required to have these mandatory fields. In addition to that, there are these conditional and optional fields. But those conditional optional fields, are not necessarily required for everything. But if you have them, they would really like to see those populated inside your data sets. And so, having this data and having that kind of mindset around it is really important. I recently had to give a presentation in Montana, actually, about this concept of how we operate today and how we operate in the future. And what we talked about is that collaboration becomes really a key element. In the world of our own enterprise GIS systems we run today, in some ways, those can be a little bit siloed, right? We have our own functions and our own purposes that we're kind of maintaining this data in. And we want to kind of keep, some control over that data. And what we're saying is not to open up the floodgates and start distributing everybody's data, but we want to build crosswalks so that way, when we are collaborating with one another, when we're sharing data with one another, we have some control and understanding of how they're going to use that data and then how we're going to get access to that data. And we're going to talk a little bit more about that here in a second. I think the other thing is this idea of supporting communications at every level. I mentioned it earlier, this idea that we're looking beyond just our local enterprise. We're also thinking about our regional environments. I know in the state of Colorado, you have many different regional deployments that are happening, like San Luis Valley and things like that. But also, we need to move up into that statewide level. There will be a statewide level effort that's going to be driven here. And this idea of interconnected networks, kind of serving everybody is going to be important. So communication and being able to kind of talk with our neighbors, resolve boundary issues, identify places where we have street center lines that might not necessarily connect or overlap with one another. There's going to be a lot of data maintenance that's going to be driven by the communication we have with our neighbors and even within local jurisdictions within our own enterprise, right? So it's really important we think about that level of communication. The next thing is education. We need to build awareness. We need to build participation in this migration process. We need to evaluate if everyone has the skills and abilities to implement this system. There could be folks that don't have necessarily all the resources. So how do we facilitate that for them? How do we give them the tools or the resources to make it easier for them to go ahead and comply with these requirements we have for NG911? And of course, there also needs to be this underlying need for a governance, a way to sustain the system. It's not necessarily the stick and the carrot, right? But I'll give you a great example. My dad was a school teacher for 30 some odd years. And my dad always had a saying. He says, you never let the kids grade their own tests. And the reason he never let the kids grade their own tests is because he didn't know whether or not were they going to give their friends a better grade if I let them go ahead and grade their own tests, were they actually going to do, identify which ones they got for wrong answers. And so when we do this comparison of everybody's data, we need to recognize that, it needs to be some level of an independent source to look at this data and make sure we're measuring everybody's information equally. If we just were to go through and ask somebody, hey, is your data ready? We might get a quick answer of, oh yeah, I'm all set to go. But if we take a real close look at how that data is being managed, we might find that there are anomalies and strange things that are inside of it. So education is going to be a big part of that. So this is where things get a little sticky. And I'm definitely sharing a little bit more of one of Brian's slides here. It's one of my favorites. GIS data management challenge that we have, or the challenge that we face, is that we don't know what we don't know. And we have to start from somewhere. And like I said earlier, this idea that if we go through and we just say, well, this is all the things I need street center lines, I need address points, I need boundary data. And our folks locally might sit there and say, sure, I've got all of those things. But then when we start looking at the data and we start realizing all of the standards that they need to meet, they go, okay, wait a second, maybe I don't have everything I need. Oh, maybe I don't have those attributes. So we need to talk and help them kind of understand what they need to do and what they need to deliver to us so that we can all kind of become knowledgeable experts. This Dunning-Kruger effect is a great example of where we kind of start off with this great amount of confidence, but we don't really have a whole lot of knowledge. And as time grows, we seem to get better at it. But what came out of the Dunning-Kruger, if you actually did a little research around this, it's sort of interesting because the people that know the most about GIS are sometimes the people that grade themselves the harshest, and vice versa. The people that know the least are the ones that go, oh, I got this all covered. So this is kind of the idea of what we'd run into with this data management challenge. So how do we develop this transition plan? How do we kind of make this migration? Well, the first thing we need to do is we need to identify who our stakeholders are. We need to start gathering our information. We need to go through and assess that data quality that exists out there. Run some gap analysis through the purposes of validation processes and things like that. We also need to look at our own internal systems. Are we finding that there are deficiencies in the way that we create data, right? That's a really important one because we might find that although we, when I say we, the proverbial we, might be a county, right, or an emergency telecommunication association, right, where you have multiple agencies underneath you, you might find that the folks at the local level may not necessarily be creating address points the way you want them to be able to be created. And so they could be producing more errors into the data just by their own processes, not necessarily by doing something that was wrong, just a different way of doing that same process. So, and then of course, next steps. Got to publish that data. So let's talk about identifying the stakeholders. When we think about public safety, and I'm assuming totally that a lot of folks that are in this room kind of fall into this role of, the public safety stakeholder range, right? You are coming from a 911 environment. You may have public safety. You might sit inside the public safety space. You may be in fire or something else. This is how we think of our public safety stakeholders today. But when we really start to go through and expand our vision of where are our stakeholders, we might find that our stakeholders exist within the IT department, inside the assessor's department, GIS, you name it, right? There's all kinds of folks who are out there. We actually had a project we worked on in California where this is a large metropolitan area. There's 1.3 million people that lived in this one particular county, and they had an issue with their addressing points. What we found was they started off, they had 250,000 address points. However, they had 10 different authoritative address databases, and they were all siloed separately from one another. And when we actually cross-compared all of those data sources, what we found was that we identified 200,000 potential address candidates. Now, this wasn't that everybody had something missing. It was just that there were certain aspects of addressing that weren't necessarily the responsibility for one entity over another. The water department did something different than the folks that were part of the wastewater and the trash department. There was another group that was handling the addressing for the building permits and so forth. And each one of them had independently kind of either started with somebody else's data and then grew their own, or they'd gone off to do other things. And when we did those weighted comparisons and started evaluating where we found all these different addresses, what we determined was there were about 70,000 questionable candidates that really kind of fell out. They weren't real addresses. But we did find that there was about 130,000 new addresses that needed to be created. And so that became part of this process. So you can imagine, just think about your own scenario and how data is managed internally within your own organization. And are there other people that are stakeholders inside of your environment, inside of your enterprise, that may have created their own authoritative address points, or street center lines for that matter? Next, we want to talk about information gathering, right? Where are the roles and the responsibilities? Who's going to be in control of this data? When we talk about roles and responsibilities, I kind of break it up into two different categories, right? There are people that are owners of data. An assessor might own the data, but he doesn't necessarily, own the GIS element of that data. He's supplying it to the GIS resource, and they might be the ones that are plotting the information on the map. The person that is in the GIS department becomes really more of a steward of the data because they are themselves not assigning the address. The addressing authority is, but they are the ones populating the map. So we have owners and we have stewards. So think about it from that perspective. Of course, the other one we have is just users. And sometimes even users don't realize they themselves think of themselves as stewards, which is like the example I just gave you. When we look at our workflows and the business processes, how are addresses requested? How do we assign those? How do they get entered into the system? This is all part of understanding those workflows and those business processes I talked about earlier. And then, of course, we need to start thinking about the GIS data itself. What is the data quality, right? And here's what I mean when I talk about data quality. What I'm talking about is this idea is the data available? You know, do we have the information we need for NG911? The next question we have to ask is it complete? Are all the necessary parts of the data present? Or do we need to start thinking about parsing out the fields, or do we need to think about adding additional attributes we may not have already? So, you know, is it 100% complete? Am I going to have to start doing a little bit of work? How do I start to maintain and keep this moving forward? And then, of course, accuracy. Accuracy is really important because when we think about accuracy, we think about, well, is the point on the street, you know, on the address point of the house, is it sitting in the middle of the structure, or is it sitting in the middle of the driveway? Is it consistent, right? So are we still seeing it that way everywhere, or does one municipality do it one way and another does it something else? So those are kind of one of those things that the accuracy of data is also about the correctness and how well it reflects the real world. Timeliness, we're talking about this idea of how frequently can I get these updates. There are certain scenarios where I know PSAPs that I've worked up here in Idaho where they might only get an update to their mapping information once a quarter. Whereas what we're talking about here in an NG911 environment can't be that way, right? We need to be able to have a 3-day turnaround. If there is something that was found as an anomaly, how quickly can we turn that back around? We can't wait for 3 months for something to happen. We have to try and keep that moving forward very quickly. And then, of course, consistency. Am I going to be able to keep getting this data the same way every time? Brian and I talked about this many times, and this idea that when he was working in this environment down in Arizona, things would change within the schemas that he was working in, and that would actually end up breaking systems that he developed for ETL processes. And so how do we improve upon that consistency of data? How do we lock down these standards that we expect everybody else to live by? And so having that ability to consistently get the same data is very important. When we run the validations to look at this information, one of the important things that most people may not understand from the public safety side of the house, but a lot of people on the GIS side of the house really do understand, is they've never looked at their data this way, right? They've never looked at it from the standpoint of being used for a mission critical life-saving application like what we're talking about. We've used it for other things all the time. But when we talk about running these validations, it can be a little bit overwhelming. And we need to make sure we don't get confused by this idea that running a validation check for NG911 is the same as what we do for CAD. They're really different. In a CAD environment, we might be looking at the idea of what the closest unit is, but we're not necessarily focused on, you know, the accuracy and the positioning and where all of the breaks in the emergency response areas are, and how that's reflected inside of our CAD system. So there's a lot of things like that where we have to think about, you know, we're not doing this the same way we've done it in the past. And there's a lot more complexity when we start doing address point comparisons to road center lines and all of these other different things we're doing. It's something that a lot of folks haven't done in the past. We have to think about data validation as kind of almost being like a debugging program. We are identifying the flaws and anomalies in the data. And more importantly, what we're trying to do is trying to create these scenarios. So if I go through and I fix a road center line, am I potentially now going to have to go back through and run my data again to see if I've impacted my address point file? That kind of stuff happens all the time because we're running so many different checks. I know we'll be talking a little bit about that later with Brian when he gets into this, but we want to make it so it's not this Herculean effort. The idea behind NG911 and GIS for NG911 is that initially there's going to be this very steep learning curve and a lot of folks are going to have a lot of work to do. But as time goes on and as we fix all these problems and we continue to run these validation checks, there are going to be fewer and fewer and fewer items for us to resolve. And so, like I said, at first it might seem like it's a whole lot that we've got to go through. ideally, this should come down to the point where it's a simple everyday run of validations you might do, and then we deliver back out, oh, I need to fix this 1 or 2 items. But this is going to help you get there. And you got to go through this validation process, you know, not just once, but many, many, many times to go through and resolve these errors. As we talked about earlier, this idea of discrepancies and deficiencies. When we think about discrepancies and deficiencies, we need to understand that we're talking about the workflow, right? We're talking about that business process. I was just on the phone here a little bit ago with somebody where their surveyor is a person that assigns all their address points, but they're still using Mylar to go through and assign the location of where an address point is. They don't even have it inside of a digital form. You know, that's a major hurdle for them to overcome, but they do have very, very accurate records, which is great. We also may want to go back through and look at, like I said, the GIS data itself. Maybe there's something we've got to add, and maybe there's some information, some legacy data that's out there that might help us. So determine where did this data come from, understand the workflow, the business processes it went through. And, you know, if you're looking for some great examples of documentation that have been provided by NINA, these are 2 great examples as far as the existing plans and strategy, that idea of these standards that are out there, whether it's talking about GIS data stewardship for Engineering 901, or whether it be the CLDXF standards for the breakdown of addresses and so forth. I really think that if you get a chance to go through and take a look at these documents, it might help answer some questions. But it's definitely not what we want to spend a lot of time on today. So show me my easy button, right? That was the purpose of today's call and why we wanted to go ahead and have everybody here today. And so what I've asked Brian to do is come in and talk to you guys about our product called Datamark VEP. Now, this is a cloud-based environment. The idea behind this is that it does provide a lot of flexibility. We can really use this product from anywhere. There's a ton of efficiency and scalability when we talk about cloud-based solutions. It's also something that's extremely user-friendly. So I don't have to become an ArcGIS Pro user in order to leverage this tool. I have access to it. I can go through and interact with it as I need to. And of course, it needs to be an intelligent system. Standards are already built into this. They're based on the NINA standard. And as those kind of change and evolve, which they have been changing and evolving for quite some time, we are the ones that take on the responsibility of updating that information and getting those new standards into the system. So you don't have to go through and spend your time figuring out how to write, you know, Python scripts to go ahead and adopt these new standards that are out there when they change something from being optional and conditional to a mandatory data set. It's already going to be done for you. And of course, it's a role-based system so that we can have many different folks, you know, interacting with this. Like I said, some of them may not even be GIS folks, to be able to provide information. We even have administrative roles where data can be aggregated across the entire state or region. So that's really kind of a fun part of what we can kind of share with you today. So with that said, I'm going to turn off my sharing and hand this over to Brian so that way he can go through and give you guys a presentation. Are there any questions at this point, Daryl?
No questions have been received yet.
All right. Can you see my screen?
We've got you.
VEP, okay. Like John alluded to, VEP comes in several flavors. It comes in a validator subscription. It's a subscription-based service. And it comes in a validator subscription, an editor subscription, or an aggregator subscription. You can think of a validator subscription. Typically, people that subscribe to the validator subscription normally, not always, but normally have very sophisticated back-end GIS systems. And they really don't need the flexibility of editing through the VEP product. They may prefer to edit using ArcGIS, Map Info, GeoMedia, or whatever their desktop product is, right? Then we have the editor license, which is kind of what I'm going to show you here. And an editor does everything the validator does, with the exception it's very flexible of where you edit your data. You can pull the information out and edit it using whatever desktop product that you have and upload those changes into VEP, or you can edit directly within the interface. And then John mentioned the last one, aggregator. Aggregator is kind of a unique animal. You don't edit through it, but you can run validations through it. And the aggregator product is specifically really meant for kind of almost a statewide implementation, to where we're pulling data from the individual counties or regional systems, and we're aggregating all that mapping information together at the state level. And then we're performing what's called cross-jurisdictional validations. So we're looking at those potential issues along the county boundary, and we're looking for things like an address point that may be duplicated in 2 counties, or road center lines that may not be snapped, or the boundaries there may be gaps and overlaps between multiple counties. So aggregator's a little different animal. So like I said, validator and editor, which are the primary 2 products here, are very similar. And the difference is that in an editor license or subscription level, we have a mapping component to it, to where the validator does not. Again, the validator component subscription is just meant to, you package all your data up in a zip file. You can optionally throw your MSAG in your alley, and you can upload that into VEP. You can upload changes, or you can just do wholesale replacement of mapping layers altogether within the environment. Once that data is in VEP, no matter whether you're a validator or editor subscription, once you've uploaded your data, or you've uploaded changes into the environment, you would run a series of validations, right? You would come over here and you would create a new validation set. You would choose to either run all validations that the system can run, or say it's been a slow month or something, and you just did or a slow week, and maybe you just did a handful of address point additions. You can just run selectively specific validations, or you can just wholesale rerun it. And what it does is, when you rerun the validations, it's going to populate this dashboard. And this dashboard has, as of our last release, which just came out last Sunday, we do quarterly releases. It performs a total of 60 validations, or 60 individual types of assessments are done on the GIS data. And some of them are very incremental. Some of them are look at the synchronization between data, maybe how well does your address points, how well does that tell the same story that your road center lines tell? What's the relationship between your alley and your road center lines, or your MSAG and your road center lines? It performs this kind of synchronization among all that data itself. Validation is very, very complex, and without a piece of validation software, it would be virtually impossible to hit this mark, this 98% measure that Nina puts out. And I would say that personally, that's too low to me, because it's totally doable to make your data set virtually perfect, to get it at 100% match rate, if you will. So we've got this roughly 60 classifications of these anomalies, and we can tell how many issues or potential issues that we have in any one given area, and their percentage of total of what those represent. Like address point misordered along center line, there's 6,746, and that represents 4% of the address points have this particular issue. It also tells you, between the validation runs, it tells you what your number of the change. Are you improving, or are you adjusting error into your data in the course of editing? Now, validation software, almost no matter what product you use, and I've used several of them today, they're cascading types of events. So what happens is if a validation fails to run due to something like maybe missing information, maybe you're missing like a street, a road type, right? If you're missing RD in the address string, it's unable to actually perform certain validations that fall underneath of that. So what happens is that when you're editing this data, you may correct an issue in one area, and that single correction may actually correct things in other validations, but it may break things in other validations. So as you're performing this wash, rinse, and repeat cycle of editing data, validating it, pulling these markup tables out of the system that tell you where you have these issues, and then edit your data some more, you're going to improve certain areas, and some areas are going to go backwards, right? You're going to actually break things in the process. So it's this very iterative cycle of wash, rinse, and repeat between the editing and the validation. So, VEP gives you things that give graphing, it tells you that, where you're improving or you're not improving, right? So it performs pretty much everything that you would think. Under the hood, it's a very sophisticated system, or the database is a very sophisticated system. It's a multi-user system, meaning that I can have multiple people editing the same data at the same time. There's also a pretty major feedback loop in VEP, and it's something that I really appreciate. When I was in Arizona, and I was we held an annual education and training symposium, I was asked to do a debrief on the Arizona testbed project for NextGen. My big takeaway from that whole a little over a year of my life, between working with Nina and working on this NextGen project, was the absence of what I refer to as a common operating picture, and the lack of communication. I was dealing with eight addressing authorities, 2 military installations, 2 tribal nations, and two municipalities, right? Incorporated municipalities, and a county government. And I work for another municipality. All of those agencies had different standards for their database, right? And they're consistently changing, and they're consistently giving me different formatted data that I was expected to kind of maintain this record of authority for this regional system. That became a really problematic workflow, right? Because there was all these changes occurring. It was really obvious that we were never going to be able to hit that 72-hour return on issues within a system. We had a communication problem. We had a standards problem. That's where VEP comes in. When you upload your data into VEP, you don't have to change your database standard. We take what you have. It doesn't matter what you call a road center line, doesn't matter what you call an address point, it doesn't even matter what you call the individual attribute fields within each of those mapping layers. Because what we do is we onboard that data set, and we teach VEP what that data set looks like, right? Once we teach it what it looks like, we can now upload that data over and over again based on that standard. Not only can we upload it in that standard, we can download it in that standard as well. So when you look at something like the download functionality in VEP, this is really neat. Say, for instance, if you were going to provision data to an EZINet, the data in VEP lives in a strict NINA compliant standard. If the standard changes, we change VEP. You never really have to worry about that, right? So when you're uploading your data, you can upload it in whatever your road center line looks like today. You don't have to completely turn the model or completely comply with the NENA standard, right? As long as you meet the minimum technical requirements for the mandatory fields, you're good to go. Once we teach it, VEP is going to recognize it, and it's a very quick process to box your data up in like a zip file and upload it into VEP. Now, what's cool about VEP is that, say, one day I'm going to provision my data into the EZInet. I can just download my data exactly how this is showing. But what if I wanted to support a CAD system or some other business system, or I just wanted my data out in the same database standard that I'm using on the back end? That's what we call a native schema. And you can have multiple native schemas in a system. In other words, as a user of VEP, you can teach VEP what you want that data to look like, either coming out of the system or going into the system. So for instance, if in a regional system, if I inherited, say, another addressing authority, I can teach VEP what their data set looks like. And after I teach it, I can then upload that data and then pull the data back out of the system in that same flavor as a NENA schema. In other words, the native schema, you might have 10 different database models. You might have, again, one for a CAD system, permit management, or some other business system, right? So it's very flexible in how it operates. Again, once you teach VEP what that database model looks like, and you can perform that teaching function either in the upload process itself, as you're pulling a data set that's never been into VEP before. You can teach it and give it a name and save it, and that name will show up here. You can also use it to download information. Now, the mapping functionality in the editor subscription itself is really nice. And VEP as a whole is super flexible because it can support very, very rural shops that have virtually almost no GIS talent at all or skill set at all. You know, we may have a client that doesn't even have any GIS software at all. They can edit in this environment, right? And since it's an enterprise solution, everything that's performed in VEP is logged. I can go through and look at a particular address point, and I can look at exactly what has been done to that one record over the course of years. Every edit is logged. Everything that results in a change of data in VEP requires administrative approval, right? So if I'm a user, if I'm an editor inside VEP, what I would typically do is I would come in here into like an editing function here, and I would create a version that I want to edit in. In other words, a version is like my own little private world, right? Nobody else sees these data additions or modifications that I'm performing, right? All they see is this kind of this parent view of the map, right? So I can sit here and I can edit this data all day long. Nobody sees what I'm doing, right? Until at some point, when I say that, hey, I want to submit this particular editing session. And this editing session could last minutes, it could last months, right? So once I'm happy with the changes, what I do is I submit that actual edit session. When I submit it, VEP sends an email by default to the administrator, and then optionally to anybody else that I want to notify that I'm submitting this update to the data. The administrator then again receives an email, so he knows he needs to go into VEP, and the administrator is going to come into the system, and they have the opportunity to review these changes within the system. They can approve them, they can reject a submission. If the administrator rejects an edit session, VEP sends a notification back to the editor along with the administrator's comments on what the administrator found wrong. The editor can then go back into the system, make those edits, and resubmit it back to the administrator. Everything in VEP that's performed in VEP has this feedback loop, including the most basic of functions, which is something like this observer widget. An observation is something, again, VEP is a role-based system. You have, people that are assigned to be administrators, people that are assigned to be editors within the system, people that are assigned to be observers, or just to read-only users, right? You would typically give an observation role to somebody that has no mapping experience, but may be exposed to the map quite a bit. Think of a dispatcher, right? They're using the map all day long. They may encounter problems with the data, right? So what an observer is able to do is they're able to grab this little observation point, mark a place on the map where an issue exists. It's automatically going to calculate the approximate address for that location. They can give it a title. They can give it all the information they want. They can attach files to this, right? They can attach pictures, Word docs, whatever, right? They can attach to this location we just plopped on a map. And then we can tell it who we want to notify, right? So, we can tell it, hey, I want to notify all the administrators about this particular issue that I found. I might want to notify somebody that's not even a part of the system, right? That isn't pre-configured, right? I can just type in a random email, and VEP is going to send them an email about this, along with a snapshot of this map, right? And all the details that have been associated with this particular observation point. Now, what I really, really like about this, and something I've never had before in my previous life, again, VEP is all about communication. It's about providing feedback, closing that loop, that communication loop. When I submit this observation point and VEP sends that email to whomever you're telling it to send it to, and say I'm the administrator and I'm going to come in here and I'm just going to review these observation points, I might come in here after receiving the email and just kind of review these observation points. As I'm working with this, I might be assigning these editing tasks to an editor, right? And once it's resolved, I could actually come in here and mark a particular issue as resolved. Once I do that, the person that actually submitted that observation point, the observer, is actually going to get a return email back with whatever comments that we put in this line item, along with the disposition of that particular point. So they don't feel like they're feeding information into this kind of this black hole, if you will. Again, everything that you perform in VEP is logged at a very, very detailed level. There's all kinds of functionality in here that supports everything from a very rural shop to a very sophisticated shop. Now, when I talk about a sophisticated shop, I might have things like in this layer configuration. I might want to configure things like attribute transfers. Think about like a PSAP boundary. And that PSAP boundary has a field in it with, say, a PSAP ID. And that PSAP ID field also exists on my address points and my center lines. I can configure VEP as an administrator to take and transfer that PSAP ID from the PSAP boundary onto my address points and left and right of the center line upon the creation of those elements. I can configure it to say, hey, when I place a new address point, I want you to automatically associate the road that I'm telling you to associate with and transfer all the street naming and all this information from that particular road segment onto that address point. So it saves you from rekeying information. It allows you to actually create a master record of certain pieces of information, like a PSAP ID. That PSAP ID, the master is in the PSAP boundary. You just want to transfer that information. You don't want to give the user the ability to to fat finger it. You want it to automatically populate, right? So as an administrator, you can make all these configurations within VEP to perform all these attribute transfers between different layers of information, if that makes sense. You can perform bulk editing in it. There's automated or very, very targeted editing tools within this environment for things like addressing, road ranging, and they're very, very targeted features. I'd mentioned before that you could edit data outside of this environment and modify the data and upload those changes back into VEP wholesale. But you can also perform what's called detached editing. And detached editing is like, you see these purple boxes. This is a detached edit boundary, right? This is a detached edit function. And when I select this, I can tell VEP, hey, I want to check out some data from the system because I want to edit it outside of the environment. I can come in here and I can draw a box around whatever I'm interested in and then tell VEP, hey, I want to check out just my address points today. Maybe I might include the center lines. And I might give this a name, roughly the date when I want to check it back in, and maybe some comments to this. What happens is when I save this configuration, it's going to create this shape that I drew, and it's going to lock all the center lines and all the address points down in this area. Nobody else can edit it. They can't edit it through uploading new data. They can't edit it through the VEP interface, because I've got this area checked out of the system. So I can edit this data over the course of months, and then when I'm done, I can check this little bit of data back into the system, and it releases the hold on this, and this little purple box will go away, and it will release the lock that is associated with this particular area. It also has other things built into it. We can configure our own base maps. If you're familiar with base maps out of the box, it has the Esri standard base maps. But if you're a sophisticated shop and you have what's called an ArcGIS enterprise solution in-house, which means we're publishing mapping data, making it available through the web. That publication through those interfaces have kind of like a URL, and you can plug these URLs into the system and actually add to the base maps. You can add a URL for these REST endpoint services for locators. So when you key in an address, it's actually utilizing your GIS data to locate that point or locate that address along the center line. So it's highly configurable. There's full-fledged reporting, change logging. Again, I mentioned that that you can that every change is logged in VEP, and there's this trail left behind. There's user metrics, edit metrics, observations. So there's all this reporting that results in these Excel spreadsheets that the system creates. Probably one of the last things that I want to cover here is a SoundX. The SoundX works like in the platting process for a new subdivision. A contractor or developer is typically going to submit that plat, and they're going to request some new street names for that particular subdivision. If you're part of that approval process, and I know that our public safety agency was back in Yuma, they had to actually, those street names had to go through an approval process, right? First of all, you want to make sure that, hey, that street name's not already utilized, right? But from a public safety perspective, we want to make sure that there's not another street that maybe sounds like that proposed street. So just for the lack of a little creativity, I'm just going to put like Main Street in here in this search algorithm. And what it's going to do is it's going to return if I have streets that are already named Main. Like, I already have Main, 12 records that are all in caps, one record that's in camel case, and 2 that maybe kind of sound like or contain the word main. So it's going to actually search for things that kind of sound like or even contain the word main. So this can kind of be used in that approval process, if you will. John, do you think there's anything else that I haven't covered? Because we only have like 4 minutes left here.
Well, and actually, I know that we do have a question as well.
Yeah, so Matt submitted a question, says, would you provide a brief descriptions of which NG911 functional elements operate using the GIS data and how?
What, I'm not sure. Could you, Matt, could you restate the question?
Yeah, so we have the ECRF and the LVF that receive data from the spatial interface, right?
Right.
So we've talked a lot about the data that's needed and the significant need to work with our local GIS data partners or otherwise to provide that data. But I think it would be great if we could just have a very brief rundown of how that GIS data actually gets used so that we clearly understand why it's so necessary. So if we talk about the location validation function.
And the emergency call routing function, yeah, one is actually just a check, and the other one is actually the production call routing function, if you will.
Right. Yep.
Well, you know, when I did this in Yuma, I have to admit I understood very, very little about these systems of how they functioned on the back end, and I've kind of had to pick this up over the years. But from my perspective as just kind of a GIS geek when I was doing this, I quickly learned that I didn't really have to understand any of those back-end systems because all I had to do is follow the recipe, right? It's a GIS data model, it's a standard. As long as I followed that recipe, that the ECRF and the LVF functions were just going to work. They're just flat were going to work. In fact, I was amazed.
And Brian, let me jump in here. I'll help you a little bit too. I think one of the things that's really important, maybe Matt, this is where you were going with your question too, is, you know, what's the function of the LVF? How does that change, and how is it going to utilize the GIS data? And exactly. I think the really important thing to remember about this is that the LVF is going to be kind of taking the place of our MSAG, right? In fact, here's a reality check that most people really don't know, and that is that, you know, there are very few deployments of NG911 where an LVF is actually currently being used, in part because, not because the functionality is not there. In fact, many vendors are out there that provide LVF functionality, but because the carriers have not transitioned to the component that connects to it, what they call the LIS, or the Location Information Server. The idea behind an LVF is that it provides this geospatial, you know, data so that as a new telephone number is created, the telephone company can look against GIS data rather than a tabular database to assign new service areas or new services, right? That's the idea behind what an LVF does and how it utilizes this GIS data. And the important thing also that kind of combines to that is that LVF data is a replicated database. It's being replicated by what we call the spatial interface. And I kind of showed that at the very beginning of the slides. It's being replicated by the spatial interface so that both the LVF and the ECRF are actually using the same data. And this is really important because the ECRF was doing the actual physical emergency call routing. There are different components inside the SI and within an EZNet environment. The ECRF and the LVF are literally duplicates of one another. One's for the active call environment and one's for the pre-call environment. And they're constantly being updated and frequently being, you know, sent new data by the spatial interface.
Yeah, so the LVF location validation function is to pre-validate a calling device's location before it ever makes the 911 call, kind of like the MSAG pre-validates wireline addresses before they land in the ALI database. And then the ECRF emergency call routing function uses the location of that device that's been pre-validated to determine which dispatch center should get the call based on a GIS boundary for that dispatch center.
Absolutely, and you know, the ECRF is far more robust in the sense that, you know, we know nowadays that 80 to 85% of our calls are coming from wireless callers. It's going to serve the purpose of providing us location accuracy for those wireless callers as well as our wireline callers, which is the segment of what our MSAG Alley model doesn't really support that well today.
I think we had a question in the chat as well, not just the Q&A section. Someone was asking about validating common places data.
Yes.
Does VEP work with or validate common places?
So that's an interesting question, probably one better for Brian. And Brian, if you wouldn't mind jumping off mute, but I will start off with that one. And I would say that VEP can validate the location of that common place, and especially because we can use the information that comes within that data set, right? So if we know that we're trying to identify the location of, let's say, a library as a common place, we can use the services and the imagery and so forth to assign, yes, this is the location of that common place, or it fits within that location. But it's not, a common place is not validated in the same manner as, say, like an address point would be, or a street center line, you know, exists in the real world. We can assign common places to a lot of different things, even areas within buildings and structures and so forth.
And it looks like the model for common place names are going to change. Actually, in the GIS data model, there's a page specifically dedicated to diagram for how common place names are managed. And you have to forgive me because that's actually my work in that document. We've come to the conclusion that it's way too complex for most people to deal with. And the discussions within the NINA world, it looks like that may end up getting retooled. Not sure. Don't hold me to it. But.
It looks like we may have another one. Oh, but this is actually a question for Daryl. Never mind.
Yeah, I am not seeing any other questions having been submitted either through the Q&A or through chat, but I'll open it up. I know it is after 1 o'clock, but this is being recorded, so if anybody has to jump off, you won't miss anything. We will upload this to the task force's YouTube page, and the link is in the chat. If anybody has any other questions for John or Brian at this point, I would open it up.
Absolutely. Well,
okay.
You know, Daryl, I'll just throw this out there for you. I really appreciate the opportunity to be here. You guys are kind of rock stars in my eyes. I was telling Matt that when I went through and got my EMP certification, I sat in on all of the Colorado 911 meetings so I could go through and get my EMP passed. And so it's really a privilege to be here and be part of this. You guys are awesome. I would like to throw in one quick plug for you. Next week, through the entire week from beginning to end, Datamark is going to be hosting what we call the Datamark Rise event. If you haven't gotten a chance to go through and look at what's on the schedule, basically Tuesday, Wednesday, and Thursday, we're going to have this open to the public. Anybody can come in and join. It is going to be a great conference. We've got some great keynote speakers and some great topics that are going to be covered. It's not just about all GIS. A lot of public safety stuff that's going to be in there. And we'd love to have the folks from Colorado join. So just Google Datamark Rise and we'll take you right to it.
Excellent. Well, thank you very much.
Yeah,
I don't
thank
see
you.
any other questions, so I think we're done for today. But thank you for joining us, everyone. This is a first in a series of lunch and learns. We're going to start doing lunch and learns in our months between our full task force meetings, so be watching for those in the future. And hope everybody has a good day.
Thank you,
Thank you so much.
Thanks, everyone.